Hey everybody, today in class we discovered the vertical line test can tell whether a graph is a function or not just by looking at the graph. So I've given us two equations to graph, y equals x squared plus 5x minus 6. You should recognize that as a parabola. There she is, crosses the x-axis in two places, so its zeros are both real numbers. And as you look at this graph, you should recognize the parabola is a function because it passes the vertical line test. When a graph is a function, we have a special notation to show, hey everybody, this is a function. So, since our equation is a function, we can replace the y with function notation that looks like this. Replace the y with an f of x, f parentheses x, equals x squared plus 5x minus 6. And that shows x squared plus 5x minus 6 is definitely a function. And then notice down below here, this notation of f of 0. The 0 is taking the place of the x. So if I want to evaluate or figure out how much f of 0 is, I'm just going to plug 0 in to my function for x. So I'd have 0 squared plus 5 times 0 minus 6. And that is actually all equal to negative 6. And notice when I go back to my function graph, on my graph, when I go to x equals 0, which is right at the origin, the y value is down 1, 2, 3, 4, 5, 6. It crosses the y-axis at negative 6. Same thing is true for if I want to evaluate f of negative 3. I'm going to plug negative 3 in for x. If I'm doing this on my calculator, I'm going to be using parentheses around my negative 3. So when we plug in negative 3 as our x value, we get negative 12 as our y value, or our output. And then on our graph, when we go to x equals negative 3, the y value is way down at negative 12. Our next function we're going to use is the absolute value of 2x minus 3. So as I go to my graph to get this ready, you should be thinking, what does this look like? You did absolute value functions in Algebra 1. When I graph the absolute value of 2x minus 3, it actually makes a v for absolute value. So again, the v is going to pass the vertical line test, so this is also a function. And in this case, since we're dealing with a new function, I'm going to give it a new name. Instead of calling it f of x, I'm going to call it g of x is equal to the absolute value of 2x minus 3. And then if I want to evaluate different x values into that function, I'll go, okay, I'm putting 0 in as my input. So 2 times 0 is 0, take away 3 is negative 3. The absolute value of negative 3 is positive 3 because it's 3 away from 0 on the number line. And then same thing, g of negative 3, if I use negative 3 as my input, what am I going to get as my output? 2 times negative 3 is negative 6, take away 3 is negative 9. Absolute value of negative 9 is 9. So my output is 9. Lastly, I've provided us a function here. I've called this h of x on the graph, a little cubic function. And we want to figure out from this graph different outputs for these various inputs. So if I want h of negative 4, the negative 4 is my x value. So when I go to negative 4 along the x-axis, the y value that's coming out of this function is 1, 2, 3, 4, 5, 6, 7. So negative 4 comma 7 is a point that is on my function, on my graph. If we want h of 0, I'm going to go to 0 on my x-axis, and the output, or the y value, looks like 2. At h of 2, I'm going to go 1, 2 on the x-axis, and up 1, 2, 3, 4, 5. The y value is 5 when x equals 2.